Today we will continue 2.8 and finish it inshallah and start chapter 4 if possible. Let's check ya shabab, what are the objectives of this section and what we have achieved so far. So I think you should ask yourself these questions. Do you know how to know that if it is one-to-one or not function? What is the inverse? What is really the inverse? From where it comes? What is the definition of the inverse? And how to find the inverse? I think we have achieved these objectives in the previous classes. Today, inshallah, we will see how to sketch the graph of the inverse and how to obtain it also from the graph of the function itself. This is the summary of this section, shabab. This is about one-to-one, the definition of one-to-one function, the horizontal line test for the one-to-one, the definition of the inverse. This is the most important part in the definition. What is the meaning of f inverse of y equals x? It means that y equals f of x. The domain of the inverse is the range of the function, and also the range of the inverse is the domain of the function. How this is also the second most important part, the inverse function property, the cancellation property, that f inverse of f of x is x and f of f inverse is x. As I told you yesterday, this x is not the same. This x is in the range of the inverse. This x is in the domain of the function. Yes, Mahmoud, what do you want?
يعني يا دكتور الانفيرس معناته عكس العملية. إذا كان طرح يصير جمع، وإذا كان قسمة يصير ضرب.
Not exactly that. Inverse function, it is the function that it satisfies this. It is more than that, more than that. It doesn't mean the opposite in the same sense, but of course it may continue something like that. The reciprocals and issues like that, but it is more than that. Whenever you have this property, if you have two functions, if you want to know that they are inverses of each other, what you should do? You should compose them. Compose them. If you get x, then they are inverses of each other. طبعا you need to compose them from the right and from the left, because you know, ya shabab, that the composition is not always commutative, but it must be in this case, not 0x. So if they satisfy this, they are inverses of each other. Of course, what you said is part of, but it is not always. Now, how to find the inverse? To find the inverse, you need to write f of x equals to y to solve it for x, to interchange x and y. What is left from this summary, shabab, is only this part. We will take it today, inshallah. The graph of the inverse is obtained by reflecting the graph of the function, and vice versa. This part also I have showed you yesterday. If you have a rational function, linear over linear, you can use this formula, but I don't advise you to do that. I don't recommend this. Do it, ya shabab. It is not difficult. Don't depend on your memory. You may make mistakes. Let's go now to the I think with you yesterday, we have solved this exercise. Let's go over it quickly. We have here a function, the square root, the squaring function, x squared. It is not one-to-one, but with this condition now, it is one-to-one. And this is the graph. If you draw any horizontal line, it will be one-to-one. The question is, what is the inverse? What is the inverse of this function? How to find it? To find the inverse, you need to do the general method, both this equals to y. Now solve this for y. But before that, usually, ya shabab, when they ask about the inverse, they will ask also about the domain of the inverse. So the domain of the inverse is the range of the function. So it is better to find the range from the beginning. And the range is about y, ya shabab. So here, y is greater than or equal 0. Y, it is clear from the graph, if you want to have it from the graph, clearly that y is starting from 0 and up. So it is y is greater than or equal 0. Or for another reason, what is y? Y, because x squared is greater than or equal 0. For any x, any real number x, if you square it, it will be greater than or equal 0. So what is this x squared? X squared is y. So this is y is greater than or equal 0. Now, what we will do, shabab, to find the inverse, we will solve this equation for x. How to solve it for x? You will square both sides or take the square root here. Here you will take the square root of both sides. Now here, when you take the square root of y equals the square root of x squared, we know that the square root of x squared is the absolute value of x. Okay? Now here x is greater than or equal 0, so no need for the absolute value, because you know when x is greater than or equal 0, the absolute value of x will be x. So this is why here we have x. If it is x less than 0, if it was less than 0, what we will do here? We will do negative x. Okay. Now what we will do? Khalas, we did solve it for x. Now x equals to square root of y. What we will do? We will interchange. You know, if you didn't interchange at the beginning, interchange at the end. So now we will have y equals square root of x. But when you interchange here, we interchange here. Look. We also should interchange here, x and y, interchange also here. Okay. Now replace y by the inverse. So inverse of x instead of y, we will write f inverse of x equals the square root of x. And this is the domain of the inverse, which is the range of the function, of the original function. Let's try to sketch the graph of the inverse of this function. Compare the graph of the original function and the graph of the inverse. Look at this and this. Let's sketch them on one graph. If you look at them, they are in fact obtained from each other if you reflect one of them on the line, in the line y equals x. Why especially this line? Because we bought y equals to x and we bought x equals to y. Here, we interchange ya shabab. So this is what we are doing. We interchange x and y. So we bought x equals to y, y equals to x. Look, they are in reflection of each other. So you can obtain the graph of the function from the graph of the inverse and vice versa. And I told you here the condition was x greater than 0. What about, this is the part, this is what we have done. What about if it is less than 0? If it is less than 0, also the inverse will be negative square root of x. X is still greater than or equal to 0. Why that will happen? I told you that you have square root of y equals the absolute value of x, and x is negative. X is less than 0. So because of that, you will have here negative x. You need to solve it for x. You multiply both sides by negative. So it will be x equals negative y, and you will interchange. Then the inverse will be negative square root of x. Okay. X greater than 0 because it is the domain here. The domain here is this, and the range, because x squared, the range is y here is greater than or equal to 0. So the range of the function will be the domain of the inverse. Now let's come to generalize the idea of sketching the graph. So here, ya shabab, please pay attention. We can sketch the graph of the inverse without having the inverse if we have the graph of the function. Look. We know that if f of a equals to b, then what is f inverse of b? F inverse of b will be a. This is the definition of the inverse. This means that the point a and b, it is on the graph of the function f and only if the point b and a is in the graph of the inverse. So what we did, we interchange x and y. Okay? Here, this is y, this is x. This is what we do usually when we find the inverse. So this means that we get the point B and A from the point A and B by reflecting in the line y equal x. We bought y equals to x, x equals to y. Look how it looks like. The graph of the inverse is obtained by reflecting the graph of the function in the line y equals x. The same. The graph of the function obtained from the graph of the inverse by reflecting it on the... Please, Shabab, mute yourself if you don't want to ask. Let me mute all. And if you want to ask, you can open your mic. Look at the graph here. Look at the graph. If this is the graph of f, this will be the graph of the inverse. Just it is a matter of reflection. So we just reflect this point. It is a and b. It will be here b and a. We will see that in the next example clearly. This is the example. Now, in this example, he asks in part A to sketch the graph of this function. This is so easy, ya shabab. Do you know how to sketch the graph of this function? So easy. It is, let me put it a little bit down. Now, this is, ya shabab, the square root of x. You know that the square root of x is like this, starting from 0. This is y equals square root of x. When you have x minus 2, it is shifted to the right. You need to remember, Shabab, the transformation techniques, the graphing techniques. So now this starts from 2 here. So this is the graph of y equals square root of x minus 2. This point, شباب, it is 2 and 0. X is 2, y is 0. Now, in the second part, he said use the graph of the function to sketch the graph of the inverse. How to do that? Without having the inverse. طبعا he asks for the inverse in the last part. So if you have the inverse, you can sketch the graph. This is not difficult. How to obtain the inverse from the graph of this? What you need to do, you need to draw the line y equals x. So here, this is y equals x. The same line that we have before. Now to sketch the graph of the inverse, what you will do, you will make a reflection now. What is the reflection of the point 2 and 0, Shabab? When you interchange x equals y, y equals 2x. So
0 and 2.
It will be 0, x is 0, y is 2 here. It will be here. So this point now, this is 2. This point will be now 0 and 2. Now the point here, for example, when we have, for example, let's say 6. If we have 6 minus 2 is 4, square root of 4 is 2. So we will have 2. Okay. And this is, of course, if x is 6. So we will have 6 and 2. This point, 6 and 2. What it will be? It will be 2 and 6. It will be here. Okay. And so on. If you reflect the points, you will have something like this. Make sure you are engineers, ya shabab. You will be, inshallah, engineers. So you have to be good in geometry and sketching the graph. Is this a reflection on this? Is this the image of this? If this is a mirror, if there is a mirror here, is this a reflection for that? Let me show you in the next slide. It is much clear. Here it is. So this is the graph of the inverse. Even I don't know what is the inverse, what is the equation of the inverse exactly. But I know that it is. By the way, if you are smart, you can know even what is the graph. Who can tell me this is the graph of which function, Shabab? Can you know it from the graph?
Inverse.
Squared.
Square.
This is the graph of y equals what?
Y equal x squared minus 2. Plus 2, sorry.
Plus 2. There is something else. Not only that. This is not one-to-one, Shabab. It cannot be inverse. The function and the inverse.
A condition.
If x greater than 0.
Greater than or equal 0, not 2. 2 here is for y, Shabab. Be careful. So you are right. This is the graph. We will see that now when we find the inverse. Let's find the inverse. To find the inverse, ya shabab, to find the inverse, we have y equals square root of, let me do it for you here. Now, to find the inverse, what we have? We have y equals square root of x minus 2. What is x, ya shabab? Clearly that x is greater than or equals 2 here. It starts from here. You cannot have x less than 2. This is the domain of the function. What is the range? I advise you always to find the range, ya shabab. What is the range? Y is what? Clearly from the graph.
Greater than 0.
Greater than or equal 0, clearly, because we have square roots greater than or equal 0. Good. Now, what we will do, we will solve it for what? We will solve it for x. We will square root. We will square here. Then we will move. Let me write x here. X equals to what? Move this to the other side. Here we are. Now interchange. So let me write here what is x. X is greater than or y is greater than or equal 0. Now let's interchange. So it will be x squared plus 2. Interchange here also, shabab. Now this is the domain. Now you will write in the last step f inverse of x is x squared plus 2. What is x? X is greater than or equal 0. So this is the inverse. This is the domain of the inverse. And this is the range of the inverse. And it is clear. Look, x greater than 0, y is greater than 2. So what we have learned from this example, you can sketch the graph of the function from the inverse and the inverse from the function. But you have to be careful. If you are not sure, find the inverse if possible and then sketch it. Great. Now we are done, ya shabab. This is of course section 2.8, but there are many tricks that I want you to have an idea about. Here we have solved exercises. I will leave them for you because they are quite similar to the examples, just for more practice. But there are some that I should mention here, like this one. Here you have the function. This condition, ya shabab, is for the inverse, not for this. Of course, here it is the domain. Of course, it is x plus 5 greater than 0, x greater than or equals negative 5. So this is the domain. And it is one-to-one function for sure. So find the inverse. Now, to find the inverse, what we will do, we will put y. Then it is better يا شباب to find, if you want to find the inverse and the domain of the inverse, if they ask about that. So it is better to find the range. What is the range يا شباب of this function? It is, by the way, it is the same, but starting from -5 like this.
Greater than or equal 0.
X is greater than or equal 0. واضح من الجراف, or from, of course, the square root. Now you should do that. It is better because this will be now this will be يا شباب the domain of the inverse. خلاص, I know what is the domain of the inverse. Now square both sides, solve it for x. Here, now we have here, when we square يا شباب the square root, do we have absolute value? No, this is x always, because x is positive. Otherwise, it is not defined. But if you have square root of x squared, this is the absolute value of x. So be careful. Good, so this is x plus 5, and the same now we will solve for x. We will move 5 to the other side. Okay, so who said it is about minus and plus? It is not. Look how this looks like and how this looks like. So this is the inverse now. Interchange, now we will interchange. When you interchange here, also interchange here. X will be y, y will be x. And now in the last step, we will write the inverse. The inverse is x squared minus 5, x greater than or equal 0. Excellent. Now, this is a very important one. Let me make 3 stars. Because I have noticed that there are many questions in the old exams about this idea. And it is clear. I made it here very clear. You can do that, ya shabab, algebraically and geometrically. How to do it algebraically? It is not difficult. You can, let me see what I did. No need for that. I think it should be, oh, no need. I don't like that. So this should be, I think, after this. No need to do this at the beginning. So forget about the graph now. What you need to do, as usual, you know how to do that. So let me forget about this. I think it is here. Just to save time, forget about this for a while, Shabab. I will explain that. Now, what you will do to find the inverse algebraically, you will put this y equals to 4 minus x squared. X is between 0 and 2. Why y is between 0 and 2? Of course, you can find it from here because x squared is between 4 and 0 because they are positive. You can, when you multiply by negative, it will be, of course, here -4 greater than 0. When you add 4, it will be x squared less than 0 greater than 4. When you take the square root, we have here 0 and we have here 2. So this is y between 0 and 2. So it is less, I didn't change here, so it is greater than. This is greater than, less than, and you should be careful about that. So here it is greater than, less than at the end. Now guys, this tell me that y between 0 and 2, this is why it is there. But it is more clear from the graph, okay? We will see that in a while. Why it is clear like that? It is much easier to do it geometrically. So if you can know it like that, it is better from the beginning. So this is the range. Now what we will do, Shabab, we will do the same as we did before. What we will do, we will square both sides. We need to solve this for x. So we will square both sides. When we square both sides, of course, no problem. Just the root will gone. Now we will solve it for x. So we will move x to one side. We will move x to here. So it will be 4 minus y squared. Now we will take the square root of both sides. When you take the square root of both sides, what you will have? You will have the absolute value of x equals to the square root of 4 minus y squared. But the absolute value, Shabab, it is positive or negative, square root of 4 minus y squared. Which one we will choose, the positive or the negative part? X equals to x equals to positive or negative. X is positive. So we will take the positive part. So here it is. Look. When we take the square root of both sides, we have x as a positive because it is, if he said it is negative, we will take the negative part. We cannot take both. If you take both, this is not a function. Now interchange. When you interchange here, interchange also here. Then this is the inverse. When this is the domain of the inverse. Okay. As I told you, Shabab, you don't need, this is algebraically. You can do it always. But geometrically, it will be much easier. How? Let me show you. طبعا يا شباب, for any question of this type, when you have y equals square root of r squared minus x squared, when you square both sides, move x to here, you will have x squared plus y squared equals to r squared. This is a circle centered at the origin with radius equals to r. So always when you have something, a number minus x squared, you will have this situation under the square root. Okay, so when it is here like 4, 2, 9, whatever. So indeed, when you see something like this, think about the equation of the circle. But the circle is not a function by the vertical line test. So what we will do, we will solve it for y. Let's say that we will solve it for x or for y. It doesn't matter. If you solve it for y, you will have the upper and the lower. This is what usually we do. If you solve it for x, it will be a function of y. Now let's solve it for y. If you solve it for y, you have y equal square root of 4 minus x squared. It was before y squared. If you solve it for y, it will be positive or negative. 4 minus x squared. The positive will be the upper part, because y is positive, so it will be the upper part. And the another one, you have two functions now. The another function is this. It is the lower part. But this function, if you take the lower part, the upper part, if you take the upper part, it is not one-to-one by the horizontal line test. So it has no inverse. We cannot talk about the inverse. So what we will do, we need more condition. And this is the condition that he gives. Because of this condition, when x between 0 and 2, we will be in the first quadrant. Now this is the y equals 4 minus x squared with x between 0 and 2. Now this is one-to-one. Now this has an inverse. Now the question is, if this is the function, what is the inverse? Who can tell me? Here it is. We have solved it before. But you don't need to do it algebraically. Just do it geometrically. How to do it geometrically? Draw the line y equals x, and then reflect the graph of the function. If you reflect the graph of this function on this line, what you will have?
The same.
The same. It will be the same. So this says that the inverse is the same. So this says that the inverse is the same. 4 minus x squared, x between 0 and 2. And I will generalize this for you, Shabab, here in the next slide. It is very important. Now, if you have an equation like that, this is the upper part, I said, this is the lower part, the same but with negative. I'm taking here with 4. You can take it in general with any number. Now here we are. So let's start with this. This is the function. Now, if you draw the line here, if you reflected about this line, this will come here, this will come here. So it will be the same. You have the same. So in the first quadrant, they will be the same as each other. Okay. This is the domain. This is the range. And it is the same. The domain and the range in this case is the same. Now let's go to the third quadrant here. I think it is similar. What will be the graph here? It will be like this. What will be the equation? It will be y equals negative because we are below the x-axis. Y is negative. 4 minus x squared. What is x? X between -2 and 0. So here it is. I did write it for you. Why I should repeat that? Here it is. This is the function. If you have this graph, the negative square root of 4 minus x squared when x between -2 and 0. Now here we are in the third. The same way, Shabab, if you did the reflection, you will have the same function. So the inverse will be the same. Okay, in the first and the third quadrant. Now let's take in the second here. If your graph is here, so it is above the x-axis, so it is y equals square root of 4 minus x squared. What is the domain? From -2 to 0. Now here we are. This is the function in the y. It is in the same place that I did right there. So here we are. This is the graph of this function, which is 1-to-1, طبعا. Now what will be the inverse, ya shabab? Just draw the line y equals x. Reflected. If you reflect this, this will come here. This is the reflection. And what will be the equation of this function here? Y is negative, square root of 4 minus x squared. And what is x? What is the domain? X between what and what? Between 0 and 2. So this is the graph of the inverse. Okay. Now, if you have this, if you reflect it here, this will be the inverse. So here we are. We discussed all the possible cases. You can generalize it for any number you have. Okay. طبعا if you don't like this, if you are not a geometry man, no problem. Do it algebraically as we did here. Do it algebraically. It is not difficult. You can do it algebraically as we did here. No problem. It's okay. It's okay. But of course, when just you need to spend some time on this to understand it very well, and it will be so easy for you. The last trick that I want you to have an idea about is when you have quadratic function. When you have a quadratic function like this is the shabab, you know that this is the general form, ax squared bx plus c. This is the general form of the quadratic functions. The standard form or the vertex form, I don't know what they call this, x minus h all squared plus k. This is when you have h and k form, okay? This is, of course, not, you cannot sketch the graph from here. If someone asks you to sketch the graph, it is not easy. If someone asks you to find the range, it is not easy. But when you have it like this, it is so easy because you know the vertex, you will know that it is opens up or down. Revise 001, ya shabab. So it is better to have it in terms of h and k. Do you remember how to find h and k? I think you do. Negative 2b over a, I think, or b, I don't remember exactly. I didn't teach 001 for a while. And h is, k is just f of h, okay? Now what you need to, my favorite way is not to memorize. I don't like, because I'm not sure, for example. So what I will do, I will do completing the square, because this comes from completing the square. So what you will do, you will just look at the coefficient of x, complete the square by adding the square of the half of the coefficient of x. We add and subtract 9. This will be perfect square. This will be negative 9 plus 4, it will be negative 5. X is greater than 3. It is good, of course. Here he didn't ask for the domain of the inverse, but it is good. I will add it here for you because you may need it. As I said, this is not necessarily for this question. Why is this? Because of course you know that this will opens up and it is shifted down 5 units. So it will start at 3. The vertex is here, negative 3 and negative 5. Here it is. It opens up like that. But since x is less than 3, it is this part only. This branch to be 1 to 1. And of course, y starts from negative 5, so it is greater than or equals negative 5. Now, what you need to do, solve it for what? Solve it for x. So you will add 5 to the other side. You will take the absolute value. Now, this is important step, shabab. Here you have positive or negative. Now, we need to remove the square root of x minus 3 all squared is the absolute value of x minus 3. Now, is it x minus 3 or negative x minus 3? It depends on the condition here. X is less than 3, which means that x minus 3 less than 0. Just move x to here. So this means that x minus 3 is negative. This is negative, shabab. Because x less than 3, like 1. 1 minus 3 is negative. This is negative. So because it is negative, we need to multiply by negative. It will not be the same. This negative, it is advisable to write it here, shabab, instead of writing it here. But it's okay if you want to write it there and simplify, no problem. So here, this will be x minus 3 equals to negative. This negative comes from the absolute value, shabab. Now, solve it for x by adding 3 to both sides. Now, we have interchange now. When you interchange, of course, you need to interchange there, and this will be the inverse. And the right answer is A. Be careful when you solve such problems, because, for example, here, look, it is the same, but with positive. Most of the mistakes will be from this choice. So be careful. That's it, shabab. This is all what we have in 2.8. I think it is time now to stop. And you have, by the way, shabab, many exercises that you know you need to practice if you want to practice more. Because I know, shabab, some of you, they prefer to practice, especially people who wanted to get higher grades. So they wanted to practice. These are the recitation. They are here, but of course you need to solve them also with your instructor. I have updated all the exams, shabab. This is the final of term 202, the last semester. This is for the final of the term before. And this is for the first measure of 192 and the final of 191. And there are many. There are, shabab, a lot of exercises here to practice. Like here we have 64, like I think, or less, because I have repeated some slides here. You have here like over 60 slides, but most of them are old exams. So this is just if you want to practice as much as you can. But please, ya shabab, I forgot to mention that. I should mention it again. Where it is, here it is. Don't, ya shabab, when you study from these slides and practice, don't do like that. So when you have the question and you have the answer, you will try to do anything to obtain the right answer. This is not the situation of the exam. The best way is to press on the slideshow. Now you are in the exam hall. Now you feel like you are in a real exam. So you have a question, you have 5 options. Now you need to write the final answer. Try to solve and try how to solve it. It is in the slides. Go back to the slides and you will find how to find such answer. Okay, then check your answer. Is it correct or not? If it is correct, good, you are lucky. If it is not, check your answer, a solution again. You should practice as the same as the exam. I don't like, shabab, the ready solutions. If you have here the solution is written, you will read it, you will not do it. So the best way to prepare for the exam is to apply the same environment of the exam, to do the same as you will do in the exam. The methods, the ways, the tricks, most of them are covered during in the slides. Now I think we are ready to say Bismillah and go to chapter 4 to give you a short introduction about it. So here we have like 5 sections, but mainly indeed 4, because these are one section together. In the first section, what we are going to study is the exponential functions. So we will see together what they are and how to sketch their graphs. Let's start, ya shabab, with the exponential function. You know what is the exponent. So like this, x to the power 2. Where is the exponent? 2 or x? Clearly, ya shabab, that the exponent is
2.
Is this exponential function?
No.
This is not exponential function. This is called the power. Just to distinguish between them, they call it power function. Okay, quadratic function, whatever you can call it. This type of functions, when you have x to the power n or to the power a, whatever, it is power function. Now, the exponential function, when the variable is in the exponent, when it is 2 to the power x, not x to the power 2. Here, this is the base, this is the exponent. So when the exponent is a variable, we have what is called exponential function, like this, for example. So this is the exponential function, shabab. In general, the exponential function with base a is defined like this, a to the power x. And what is good about it, it is defined for all real numbers x. But in 2 conditions. A is not 1, a is positive, greater than 0, but not 1. So a is not 0, not negative numbers, not 1. A is greater than or equals 1. For an instance, 2 to the power 3, 2 to the power x, 3 to the power x, 10 to the power x. These are 3 exponential functions with different bases. Okay. Now, why a cannot be 1? Why not? Because what is if f of x equals to 1? If a equals to 1, what do we will have? We will have 1 to the power x. What is 1 to the power x for any real number x? It is 1. So this is a constant function. This is a horizontal line. The graph is a horizontal line. This is not exponential at all. So this is not exponential function. So this is why they take it out from the exponential functions, because it is constant function. My question is, why a greater than 0? You should ask yourself, why a here it cannot be 0 or negative? Who can tell me? A cannot be 0.
Any number when any number is multiplied by itself, it should be positive.
No, this is not the reason. I didn't get your point. Maybe if it is
because
0,
it will be x constant.
0 to the power x. What is 0 to the power x? 0 to the
1.
power.
It's 1.
Sorry? 0 to the power 1. 0 to the power 2. It is 0 times 0. It is 0.
0.
But the problem, if we have, for example, 0 to the power negative 1, what is this? This will
Undefined.
be 1 over...
It's 0 by 0. Or
yes,
0.
you know it's about that x to the power negative 1, it is 1 over x. The reciprocal.
Yeah.
So this will not be defined. So we cannot have 0. طيب, why we cannot have negative? Like -4, for example. Why we cannot have -4? If we have -4 to the power 2, it is not a problem. This is 16. But it will be a problem if we have -4 to the power 2, 1 over 2. What is this? This is the square root
Irrational.
of -4. It is not real. It is not a real number. So this is why we exclude the 0 and the negative numbers. We need it to be defined for all real numbers. This is not defined for a half. Okay, so it is important, Shabab, to have an idea of what is going behind. So now, because of this, it is defined for all real numbers. This means that the domain of this function is all the real numbers. And also, a to the power x. A to the power x is always positive. Why? Why a to the power x? This one, y to the power x, which is y, always greater than 0. Always positive. Why? For any a greater than 1, any a not 1, for x, any x greater than 0. For any real number x. Why it is always greater than 0, Shabab? If you have a positive number a is positive. When you raise it to any real number, it will be positive. Take any example, whatever. A to the power, we will see that in the next example. So a to the power x is always positive because a is positive. For an instant, look at this. 2 to the power x, 2 to the power x. Whatever x is, this will be always positive. Always. Both x positive, you will get positive. Both x negative, like here, f to the power -1, it will be 2 to the power -1. 2 to the power -1 is 1 over 2. It is the reciprocal. Okay? So always it is positive. This is, of course, of to the power pi. So when we have y equals a to the power x greater than 0, this means that the range of this exponential function is what? Open 0, infinity. This is the meaning of having it always positive. This is when you have f to the power 5 over 2, Shabab. This is 2 to the power 5 over 2. You need to remember the rational powers, the rational exponents from MATH001. This is 2 to the power 5 or to the power half, 32 to the power half, square root of 32. Simplify much and more. So it is 4 square root of 2 at the end. Simplify as much as you can. You need, ya Shabab, to remember the laws of exponents, how to multiply the similar bases, add, subtract, outer and the inner powers, distribute over the product, distribute over the quotient, but we don't have distribution over the sum and the difference. Be careful. Be careful. This is not correct. This is a common mistake for 001 students, not for 002. We have here additional properties of exponents. Also, we have, ya Shabab, a greater than 0, a is not 1. If you have this will be used in section 4.5 more than here. If you have a to the power b equals to a to the power c, so the same basis, two expressions equals to each other with the same basis, so also the exponents are the same. Here we have what? We have here m less than n, m less than n. A to the power m is less than a to the power n. Is that correct? This is correct if a greater than 1. But if a greater than less than 1, it will be the opposite. Okay, this is if a less than 1, and of course greater than 0, because we said from the beginning that it is greater than 0. So this is very important, Shabab. Here it is increasing, here it is decreasing, because we reverse. Let me give you an example. 2 is less than 3. 2 to the power 2. So here we take a to be greater than 2 to the power 3. What is 2 to the power 2? 4. 2 to the power 3, 8. So this will be less than, clearly. But you have 2 less than 3. Now, what about a half to the power 2? We take a number that is less than 1. And a third to the power, a half to the power third, to the power 3. Now we raise, this is m, this is n, this is a. Now, this is what? This is 1 over 4. This is 1 over 8. Which one is bigger? 1 over 4 is bigger. So this is bigger. So it is not in the same direction. This is decreasing function. Now, how to sketch the graph of such functions, ya shabab? The graph is easy. Now, we don't know how it looks like, how the graph of this function looks like. We don't know. What we usually do if we don't know how to sketch the graph, ya shabab? If you don't know how the graph looks like, what you will do? Guys?
Make a table and graph it.
Yes, you will make a table and plot points. So you will use plotting points. Usually we do this when we have a new function that we don't know how to sketch the graph. So we will take some values of x. You know that the domain of this function is all real numbers. You can take any real number. So we will take 0, 1, 2, 3, negative 1 as an example. When x is 0, what you will have? 3 to the power 0, 1. When you have 1, 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3 is 27. When you take negative 1, 3 to the power negative 1 is 30, and so on. So now plot these points. If you plot this point, this is the graph that you will have. 0 and 1, 1 and 3, and so on. Negative 1 and third, negative 2 and 1 over 9, and so on. What about this function? Similarly, you will sketch, let's do plotting.
It will be the opposite.
Look, when x is 0, it will be 1, the same. But when x is 1, it will be third, 1 over 9. These values here will come here, and these values here will go there. So it is now plot the points. It will be at 1, it will be third. At 0, it will be 1. At 2, it will be 1 over 9. So it will be like this. So this is the graph. And if you look at these two graphs, they are reflection of each other on the y-axis. When we have, ya shabab, this case, if this is f of x, this is f of negative x. Okay? So this means, ya shabab, here that there is a relationship between these two. And indeed there is. Third to the power x. What is it? It is 1 over 3 to the power x. Or you can use 3 to the power negative 1 or to the power x. Which is what? 3 to the power negative x. This way or this way. It is the same. So indeed 1 over 3, it is just 3 to the power negative x. So I think I mentioned here, yes. So g, this is g of x, it is 3 to the power x, it is 3 to the power negative x, it is f to the power negative. So this is the graph of 3 to the power x, this is the graph of 3 to the power negative x. We have here a family of several exponential functions. This is 2 to the power x, the red one, 3 to the power x, the black one, 5, 10, and these are when you have 2 to the power negative x, or a half to the power x, 3 to the power negative x, or a third to the power negative x. What you can notice about this graph, Shabab? Tell me what we can obtain from this graph. What are the informations that we can have from this graph? Do you notice something here?
Everything, anything between 0 and 1 is decreasing.
No, what we have here, let's start with this. Do you notice something? All of them, all of these graphs
intersect in 0 and 1.
Are passing through the point 0 and 1. Why?
Because everything to the power of 0 is equal to 1.
Yes, thank you. Because a to the power 0 is 1. For any a greater than 1 and not equals to 0, to 1. Of course, a to the power 0 is 1. So this is 3 to the power 0, 2 to the power 0, whatever. Good. What is the another thing that you said about before?
Numbers between 0 and 1 is decreasing.
Faisal, you are right. When we have this 2 to the power negative x or a half to the power x, they are decreasing. Look, they are doing like this, decreasing. Let me choose another color like this. So they are decreasing. Oh, it is there, even this color. Okay, now when they are, of course, I think it is mentioned here. For a between 0 and 1, it is decreasing. For a greater than 1, it is increasing. For these functions, look, they are increasing. What else, ya shabab? There is a horizontal asymptote. What is the horizontal asymptote? The x-axis. They have x-axis. What is the domain? The domain, x values, x from negative infinity to infinity. What is the range? The range starts from where to where? From 0 to infinity. So we have the domain is all the real numbers. The range is the positive numbers only. Even 0 is not there. Okay? So we can summarize this here. The graph of the exponential function, it looks like that. Unfortunately, we don't have time. We will continue tomorrow. We will stop here. See you tomorrow, inshallah. If you have any questions, please.